We enjoy our lives a lot better now that technology has advanced. Imagine driving from California to Texas without needing to stop for a recharge. This is possible thanks to CATL's million-mile battery technology. Meanwhile, lithium-sulfur batteries offer energy densities up to 2,600 watt-hour per kilogram, and CATL's Shenxing Plus batteries can fully charge in just 10 minutes, and sodium-ion batteries also offer a cost-effective and sustainable alternative. These innovations are not just steps forward, they are leaps into the future. So how advanced are these new battery technologies? Solid-state batteries. Energy density is a crucial metric for electric vehicles, as it directly impacts the driving range. Solid-state batteries can achieve energy densities of up to 500 watt-hour per kilogram, a remarkable over 50% improvement over the CATL Keelan battery's 255 watt-hour per kilogram. This means electric vehicles equipped with solid-state batteries could potentially travel up to 30 to 50% farther on a single charge. For example, our Tesla Cybertrucks with a 500-mile range, which may be boosted to an astonishing 750 miles if solid-state technology is employed. Another area where solid-state batteries shine is in charging and lifespan. These batteries can be fully charged in just 15 minutes, half the time required for 30 minutes of BYD blade batteries. Additionally, they boast a remarkable lifespan of up to 1 million kilometers, over 1.25 times the 800,000-kilometer lifespan of Panasonic's 2170 cells. This translates to reduced maintenance and replacement costs for electric vehicle owners, contributing to a more cost-efficient ownership experience. Speaking of cost efficiency, solid-state batteries have the potential to reduce the total cost of owning an electric vehicle by up to 20 to 30% compared to vehicles equipped with other batteries. Based on expert research and forecasts in the electric vehicle battery industry, the production costs of solid-state batteries are currently estimated to be 30 to 50% lower than those of the BYD blade battery. In practical terms, producing solid-state batteries costs approximately $80 to $100 per kilowatt-hour, while the production cost for BYD's blade battery is 1.875 times higher, ranging from $120 to $150 per kilowatt-hour. The primary reason for this cost disparity lies in the differences in raw material costs and manufacturing processes. Lithium carbonate, a key component in solid-state batteries, costs around $12,000 per ton, significantly cheaper than the nickel and cobalt used in BYD's blade battery, which are priced at over $22,000 per ton for nickel and up to $70,000 per ton for cobalt. Moreover, solid-state batteries are renowned for their high safety and reliability. Tesla's solid-state battery tests have demonstrated significantly greater impact resistance and durability compared to traditional lithium-ion batteries. Reports indicate that Tesla's solid-state batteries can withstand impacts of up to 5,000 gravity without damage, and they exhibit exceptional mechanical properties. The solid structure of these batteries contributes to the Tesla Cybertruck's superior load-bearing capacity compared to other electric vehicles. Tests have shown that the Cybertruck's chassis can endure loads of up to 14,000 pounds, equivalent to 6,350 kilograms, without deformation. Actually, Elon Musk, known for its innovative approach, he has been actively developing its own solid-state battery production facility in the United States. He has already integrated first-generation solid-state batteries into its Cybertruck model, demonstrating its commitment to this transformative technology. Furthermore, Tesla has shown signs of collaborating with solid-state battery companies like Solid Power and QuantumScape, hinting at its intention to integrate solid-state batteries across its entire electric vehicle lineup in the near future. 2. Lithium-sulfur batteries. There's a battery that will undoubtedly surprise everyone, including Elon Musk. The theoretical energy density of lithium-sulfur batteries can reach up to 600 watt-hour per kilogram, which is an astounding 10.4 times higher than the 250 watt-hour per kilogram offered by LG Chem Ultium battery. With their high energy density, lithium-sulfur batteries will not only succeed in the electric vehicle business, but may also dominate other industries, including as aircraft and drones, grid-scale energy storage, and portable devices. Leading companies in the field, such as Cyan Power, CATL, and QuantumScape, have made notable strides in addressing the historical challenges associated with lithium-sulfur batteries, including issues related to cycle life and safety. Their efforts have paved the way for this technology to become a viable alternative to the currently electric vehicles' batteries. One of the exciting prospects of lithium-sulfur batteries is their potential to revolutionize electric vehicle design by reducing the overall battery weight by up to 50% compared to the current batteries. Electric vehicle designers would have the opportunity to create lighter, more energy-efficient vehicles. This could translate into significantly enhancing the driving experience for consumers. This dramatic weight reduction has profound implications for electric vehicle design. Imagine a future where the Tesla Cybertruck, with its current range of 500 miles, could have its weight cut by half, from the estimated 6,350 pounds to just 3,175 pounds. This would be a game changer, allowing the Cybertruck to become agile and nimble, like a sports car, while still maintaining its impressive capabilities. What do you think if your electric car was halved in weight compared to the current one? Is that really beneficial or detrimental to your current purpose of using an electric vehicle? Let us know your thoughts by leaving a comment below this video. We look forward to hearing your insights and always appreciate your comment. Moreover, the lower cost of raw materials such as sulfur used in lithium-sulfur batteries could help make electric vehicles more affordable for the broader market. Specifically with sulfur as its primary material, lithium-sulfur batteries leverage an abundant resource, with global reserves estimated at over 200 million tons. Sulfur is not only plentiful, but also highly recyclable, making it an attractive option for sustainable battery production. The current market price for sulfur ranges from $200 to $300 per ton, significantly more affordable than the materials used in Tesla's 4680 battery. In contrast, the issue of sourcing raw materials for the production of BYD blade batteries has always been a major concern. The materials include nickel and cobalt that paints a more complex picture. Nickel, with an estimated global reserve of 94 million tons, is 2.12 times less abundant than sulfur. The price of nickel in 2023 stood at over $22,000 per ton, making it approximately 110 times more expensive than sulfur. Similarly, cobalt, with global reserves of around 7 million tons, commands a hefty price of about $70,000 per ton. This stark difference in material availability and cost highlights the potential advantages of lithium-sulfur batteries over the BYD blade batteries, particularly in terms of affordability and sustainability. 3. Shenxing plus CATL battery. At the core of CATL Shenxing plus battery's superiority is its ability to charge up to 80% in just 10 minutes, a feat 3 times faster than 30 minutes of BYD blade battery. This rapid charging capability is largely due to the fast-conducting lithium-ion coating and the addition of transition metal elements, which facilitate smoother energy transfer between the cathode and anode materials. Furthermore, the introduction of a new nanometer wrapping layer in CATL Shenxing Plus battery enhances the battery's energy transfer efficiency, ensuring a more stable and faster flow of energy. CATL's expansion of the cross-sectional area and capacity of the battery terminals further complements this, allowing for quicker heat dissipation during high current charging. This is crucial in maintaining the battery's performance and longevity, especially under the high-stress conditions of rapid charging. In terms of energy density, CATL Shenxing Plus battery achieves 300 watt-hour per kilogram. This increase in energy density translates directly into greater range, with up to 1,000 kilometers of driving range achievable in just about 10 minutes charging, essentially 1 kilometers per second of charging time. Such efficiency in both energy storage and charging sets a new benchmark for the electric vehicle industry. These impressive performance characteristics of the CATL Shenxing Plus battery could significantly enhance the capabilities of the Tesla Semi, ultimately delivering tangible advantages to both commercial and individual consumers. Imagine if Elon Musk can replace a Tesla Semi with the Shenxing Plus battery. It can boast a range of up to 1,000 kilometers on a single charge. This would be a game-changer for long-haul trucking operations, as it would dramatically reduce the need for frequent charging stops. Instead of the current Tesla Semi's range of 500 miles, the Semi powered by Shenxing Plus battery could traverse the distance between Los Angeles and San Francisco on a single charge, with enough juice left to navigate the urban streets.